Okay, so we already learned quite a bit of rules in calculus. Okay, we learned power rule, we learned product rule, we learned quotient rule, and today and tomorrow we're going to be working on chain rule. All right, before we really get into this lesson, I want to talk about, well, why do we even need a new rule? So look at these problems down here. You can do all of this could have been on your last test. Okay, all of these are derivatives that you should be able to do. Okay, what's different about these over here? They have to use the chain rule. So why do you think we need a new rule? Like, what makes them different? Why are we not already able to do these types of problems? I am about to tell you. So, okay, do we know how to do x, take the derivative of x squared plus 1?
No.
Yeah, we do.
Oh, well,
Do we know how to do the square root of just plain x?
yes.
Yes, because we can rewrite it as x to the 1/2. But when you put those two things together, we have a problem. Okay, do we know how to take the derivative of just 6x?
Yeah.
Yes. Do we know how to take the derivative of sine x?
Yes.
Yeah, but sine of 6x, that's a problem. Okay, and I could keep going, but all of these are functions within functions, which is what we call a composite function. Remember f of g of x? Before this class, you have practiced that a few times, starting in Algebra 2. And so let's look at this. H of x is f of g of x. Notice this is not times. I get that parentheses a lot mean times, but this is, we call this f of g of x. It's a function within a function, okay? So I want to talk about an M&M, okay? So I want you to open up your bag and let's just ponder upon an M&M. Okay, and what I'm going to do is think about a green M&M. That's the one I have right here, and that's a color that I have.
We need to get it out.
Yeah, go ahead and get it out, and let's just look at it. Let's look how pretty it is. I'm drawing it down more or less for who is watching this video, so that they can tell what we're doing. Okay, what's on the outside of an M&M?
Chocolate.
The shell. Okay, so that's what f of x is going to be represented by, the shell. It's the outer function. Okay? The inside, which I'm going to use this color for, is going to be the chocolate. And now this is kind of a purple color, but purple is pretty close to brown, so this is just how we'll do it on the video. So the inner function, which is g of x, is the chocolate. Okay, when you eat an M&M, what do you taste first? The shell or the chocolate? Okay, so some of you are like, oh, I don't know, I kind of just chew it up really fast, I'm not sure. Okay, so this is what we're going to do, and it's going to be kind of weird. Okay, I want you to take the M&M, put it in your mouth, but do not chew it.
Oh, that's only.
Okay, so right now, you shouldn't be tasting any chocolate. You should be tasting like the sugary shell. It doesn't have like much of a flavor. Okay, so look what's happening here on the board. Okay, when we take the derivative of a composite function, the first thing that happens is the shell dissolves. And in our case, dissolving is just like deriving. Dissolving, deriving. Okay, that's the first thing that happens. Okay, while the shell is dissolving, what is happening to the chocolate?
Melting.
Okay, but isn't it in the same place it was in the beginning? Okay, I get that your body heat is probably melting it, but g of x, the chocolate, is for right now staying the exact same. Okay, so the shell dissolves, f prime. The g of x part, though, the inside chocolate, that's staying the same. Now, if you suck on this long enough, what's eventually probably right about now, what's happening?
It's gone.
The shell is gone, and now the chocolate, you can taste it, right? So the chocolate's dissolving. That happens next. Some of you, that happened real fast. Okay. So that's why the formula works the way it does. I'm not really giving you a mathematical answer. I'm giving you a very, analogy, okay? And this is a good way for you not to have to just memorize another formula. Okay, I do want you to look over here at this other formula. This d over dx of f of u. Okay, or fu. I always love saying that because it doesn't matter how many times. It's just funny, I guess. Your teachers say fu. So f of u is f prime of u times du. And here u just stands for something other than x. It could stand for x, but generally something other than x. I just wanted to throw this out here, and eventually we're going to use that u notation a lot more, but not today. Okay, so let's look at problem number 1, and let's use our analogy of the M&M. Okay, so again, I want you to take an M&M. Well, first, hold on. I'm getting ahead of myself. In this problem, sometimes it's easier to say what the chocolate is. What's the chocolate in this problem? 5x plus 2. That's the chocolate. So I want you to like circle it, and I'm color coding. If that helps you, do that. If not, that's okay too. So that leaves to the 4th power as the shell. Okay, the chocolate is the inner function, the shell is the outer function, just like in an M&M. So when we're trying to find h prime of x, when we're trying to take this thing's derivative, the first thing we do is derive the shell. So again, let's take an M&M, let's put it in our mouth, and let's remember, okay, only the shell is dissolving. So forget about the chocolate for a minute. What do you do when you have something to the 4th power? How do you take that derivative?
Multiply by the coefficient.
The 4 goes to the front, and then what would the new power be? 3. Okay, that's dissolving the shell. What's happening to the chocolate? Nothing. It's staying the exact same. So see how it was 5x plus 2, still 5x plus 2. Now I'm not done. That's just the first thing. Okay, as the shell dissolves, the chocolate stays the same, but then the chocolate starts to dissolve. So I'm going to go times. Don't choke. It would be bad. And then what's the derivative of the chocolate? Of 5x plus 2? 5. Now you don't need parentheses around this 5 because it's a single number, but we're going to get to some where it's more complicated, so it definitely doesn't hurt to put parentheses around something, okay? So we don't need it, but I'm going to go ahead and put them there. Okay? Now, at this point, as we go through examples, you can continue to eat the M&Ms this way to kind of like really help you like sink in, or you can just enjoy them as a snack. It's up to you. All right, so problem 2. I see a square root. I need to make an adjustment. What do I need to do? Yeah, square root is the same as to the 1/2 power. Now this is actually very similar to example 1. What's the shell? The 1/2 is the shell. What's the chocolate? The x cubed plus 2. So then my h prime of x would be, so we got to address the shell first. The 1/2 is going to come down to the front. And what would the new power be? Negative 1/2. We're still just subtracting 1. It's still the same old rule in that respect. Okay, a common mistake is to go ahead and put the derivative of the chocolate on the inside, but that's not what we're doing. Keep the inside, x cubed plus 2. Then go times the derivative of the inside, which would be 3x squared. Now again, this is a single term, so we don't need parentheses. I'm going to go ahead and write them because we're going to come across an example pretty soon where you do need them, and I'll explain why, but it never hurts to put those there. And we're not simplifying, and that's okay. We're not focused on simplifying today. We're focused on figuring out what chain rule does. Okay, I want you on number 3 to go ahead and identify on your own which one's the shell and which one's the chocolate. What do you think is a pretty good indicator as to like which one's the chocolate? Parentheses. Now they're not always going to have parentheses. Like we saw in question 2, there wasn't parentheses, but then we made that happen. But on most of the examples, you're going to see parentheses, and that's a really good indicator about which one's the inner function. Okay, keep in mind, this is not cosine times 6x. If it was, I would be needing to use product rule. What is this saying? Cosine of 6x, a function of a function. That's why I'm using this new chain rule. H prime of x equals. Okay, derivative of the shell. What do we got? Negative sign. Keep the inside the same, so of 6x. And then go times what? 6. And you don't need parentheses around the 6. You could write them, not write them. It doesn't really matter to me. All right, I want you to try number 4 on your own. When you're done, sneak a peek at your neighbor's paper, see if you guys got the same answer. But it's gonna be okay. Hey, we're not, that's tomorrow. Oh, it's 3 hours away. Yeah. X squared or less than. Okay, this one's a little bit different because your shell here is cosecant. So what's the derivative of cosecant? Negative cosecant. Well, look what I'm doing here. Cotangent. Did you guys do that? Well, we hadn't done one like it, so it's not surprising. So I need to do this because remember, x squared is not changing, and you've got to put it in both places. Okay, so you might have just done negative cosecant and not written anything after it. But a trig is always taken of something. Like cosecant doesn't mean anything without an x or something equivalent to it after it. Okay, am I done? What do I got to multiply by? 2x. That 2x does not have to be in parentheses, although it could be. And I'm making a big deal about that. When we get to number 7, you're going to see what I mean. Okay, number 5. Let's do this one together. Okay, h prime. What's the shell? Cosine. And again, this is not cosine times sine. I get that parentheses means times some of the time. But this means cosine of sine. The way you know is because there's no x after cosine. The x part is actually replaced with sine x. This is why we need chain rule. So derivative of cosine would be negative sine. Keep the inside, which is sine x, keep it the same. So now we have negative sine of sine x times the derivative of the inside, which would be cosine. Don't try to simplify this. A lot of people would try to say, oh, isn't that sine squared? What do you guys think? Is it? No, because this is not sine times sine. It's sine of sine. And I'm making a big deal about that because I feel like that's a conceptual thing that if you really get it, it makes understanding when to use product rule and when to use chain rule easier. Okay, if number 6 had been on your last test, what rule would you have used? Quotient rule. And we could totally use quotient rule on this. Not a big deal at all. I want to try to do this an alternative way. I want to rewrite this and then use chain rule. How could I rewrite 1 divided by 2x plus 1? 2x plus 1 to the negative 1. Okay, see how this is 1 divided by something? That since that one thing is in the denominator, it's really being taken to the power of negative 1. And now I can use chain rule. So h prime of x, same as the other ones. Here, this is very similar to problem number 1. Dissolve the shell or derive the power first. So that would go negative 1 and the new power would be -2. The inside stays the same initially, and then we go times the derivative of the outside. And again, that 2 could be in parentheses, although it doesn't have to be. Okay, this answer looks a lot different than what we would have gotten if we did quotient rule, but those answers would be equivalent. Okay, so I want you to turn and I want you to try 7, 8, and 9 on your own. And remember that whole, like I kept saying, like we parentheses, that's really important on number 7. What was that? Yeah, your M&Ms are there for you to enjoy. Okay. All right. First of all, before we really find this derivative, what did you guys do with this square root? 1/2, right? So we go 1/2 in front, keep the inside the same, and then the new power would be 1/2 minus 1, which is -1/2, times what?
9x squared minus 2.
9x squared minus 2. Now, the way I have this problem right now, it's not actually saying what I want it to say. I want this to go multiply times the whole thing, 9x squared minus 2. This is where you have to have those parentheses. Okay? All right, what about number 8, h prime? Secant 3x tan 3x times 3. You got to have 3x in both spots, and you got to have the times 3 at the end. Okay, 9 was a little bit hard because you had a cubed root and you had it to the 4th power. So how can I, like, if I don't want any of that except for just a single exponent, how can I combine the to the 4th power and the cube root? 4/3. Because if I don't combine it into a single power, what ends up happening is I have a function within a function within a function, which you guys have kind of already hinted at is the peanut M&M. Okay, and we're going to do that tomorrow. So it's actually always easier if you can write it this way to do that. Okay, so 4/3 goes in front. The biggest mistake I see is when students get comfortable with this, they start taking derivative too soon of the inside part. They forget that that chocolate isn't going anywhere. It's staying the exact same. What was the new power? 1/3. You just subtract 1 like normal, and then you're going to multiply by 20x to the 4th minus 14x. And that it does have to be in parentheses. Okay?